Hi. All right. So we have here's a really nice example of trying to count the number of arrangements that we would have from a particular word. And the only problem is that the word is classroom and it has S, which is appearing two times. And then we have the double O, which appears two times. And if we wanted to be able to count it, right, in terms of the arrangements, we can't just simply say, well, classroom, in this case, has nine letters. So the way to rearrange them is 9 factorial ways, which would be true. The only problem is that the S's are not distinguishable, right? So it's not like if we would label them, let's say we had S1 and S2, and then O1 and O2, then it would differentiate between them. And again, that case, we would have 9 factorial ways of being able to arrange them. But this comes into effect when things are actually repeating. So I'm going to use kind of the repetition with regards to multiple letters or multiple objects that are kind of repeated within. And I can put up a link up above there. I did a video, okay, with a little bit smaller item and example, so you can watch that before here, because I present on what I actually use. Okay, so for part A, in how many different orders can the word be arranged? Well, so as I already said, we have C, L, A, S, S, R, O, O, and M. So that would have been 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. 9 letters I know I can rearrange 9 factorial ways. But because of the fact that S is repeating 2 times, then what we do is, okay, so this is 2 factorial, so that we remove the ones that, if let's say S is first, S is last, it doesn't really matter. We don't want to count them 2 times. And then the same thing here. So the O's are appearing 2 times. So we would have been dividing by 2 factorial once again. So this would have been just 9 factorial divided by, I guess, by 4. Okay, so we can do that. So 9 factorial divided by, 2 times 2, so that's 4. So that's still quite a lot of ways. So 90,720. Okay, so that's the first one. Now, B is much harder. So this would have been A. Okay, now in B, how many different 4-letter arrangements can be made from classroom? That's difficult, actually, to do. Now, if we would have that we had no repeating, right? So if S wasn't repeated, if they were actually distinguishable in some particular way. So if I would take this, let me duplicate it here. We'll bring it down. And we would say this is S1, S2. Okay, this is O1, O2. So that would distinguish between my letters. Then if I wanted to make 4-letter words, we know that we can use, so this would have been 9, okay, P4. So basically, how many permutations can we have, okay, from 9 letters that would be distinct letters? Then this would have been the answer, right? But now, unfortunately, we can't really do that because of the fact that the S's are not distinguishable. We don't know which one is 1, which one is 2. So how would we actually approach this? We had a very nice way of doing it when we chose all the letters, right? We would just divide by how many times the S's are repeating in terms of factorial ways, so 2 factorial. But we certainly cannot do this. Okay, so we can't say this is 2 factorial, and then, we're done. This is actually not true, wrong. Okay, and in general, this will be wrong. Doesn't mean it's always wrong, but in general, this is wrong. And I did an example of this as well, okay, in that video that I was linking for you. So if this is incorrect, then we have to do, certain cases. So we know we're going to be picking 4-letter words. So 4 letters. So what I'm going to do is I'm going to kind of break this down into cases. So here's case number 1. Okay, and this is what I would encourage you to do. For your case number 1, always try to pick, let's take all the letters, okay, but not repeat them, right? And then say, okay, if I did this, so now I actually have only 7 letters in total. And how many different ways could I rearrange them? For this, indeed, it's 7p4, right? So how many permutations are there? So that is true if I would take that. So that's the case when there are no repetitions at all. Okay. Now, case number 2. So now I'm going to start picking off all the cases, and let's say, okay, they are repeating. So let's imagine, okay, so in terms of the next item, okay, that I'll do, is what if both of them repeated? So I had an O and an O, and I guess an S and an S. Well, if I'm choosing 4-letter words, okay, so in this particular case, right, and I only dealt with these, so in how many different ways can these be rearranged? Well, this is fair game. So I can literally say I have 4 total letters, okay, and then this would have been 2 factorial divided by 2 factorial. So I can use exactly what I did in part A, except just with 4 letters, 1, 2, 3, 4. And this would give me the total amount. So now that's case 1, and now case 2, and both of them have actually repeated. Because I can't have any more letters, right? There's only 4 letters in total. So that's 4 factorial, would have been 24, divided by 4, so it's 6 different ways that I can rearrange these. Okay? So that's what I would have had here. Now, what other cases can I have? So case number 3, and this is kind of what you would have to go through is, okay, so in the next one, okay, is what if I was repeating only the O's? Okay? What if I only repeated only the O's? And now the rest, okay, of the letters that I would have, okay, what else is remaining? So that means all the other letters could only happen once. So in that case, so that would have been the C, the L, the A, okay, the S, the R, and the M. Okay, so I can pick 2 letters, so any 2 letters that I want, okay, and then bring them in here. So now notice, so what I would have is I would have 1, 2, and some 2 other letters. So what would that be? Well, so that is 4 factorial divided by just 2 factorial because the O's are repeating, right? That's with any 2 of those letters. But of course, I could pick, CL, I could pick CA, right? I can pick CS, okay, to be those 2 letters. So, how many different choices would I be able to pick out of here? Now, if you would do all of that, so if you did CL, CA, really, so what you're having is you have 1, 2, 3, 4, 5, 6 different letters, and you're only choosing 2 of them that you like, right? Now, the order here doesn't matter because if you say CL or LC, they're still the same letters, and then they're being rearranged there. So I have CL, CA, CS, okay, and of course I would have CR and CM, okay, so I would do that. So that's kind of takes all the C's in, and then I would do the same thing. So I can have, LA, then it would have been LS, it would have been LR, would have been LM, okay? So that's all the different ones for that, and then I can do the same thing. So it would have been AS, right? AR, AM, okay? And then finally, you would have SR, SM, okay? So those are the only ones, and then RM. So in total, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And when you study finally, when you have kind of combinations, right? And when you get there, then this, okay, this is just a hint for you. I did it by brute force, but this would have been 6, choose 2, which indeed is 15. But you get to that when you study actually combinations, okay? And maybe you haven't yet, so I just did it by brute force. So there's 15 different ways, okay, that I could do this. So that's case number 3. Okay, so that's 15 different ways of choosing those 2 letters and then multiplied by how many times I can rearrange the O's with those 2 letters. So that's would have been that. So that's 15, I guess 4 factorial, so that's 24 divided by 2 factorial, so that's 15 times 12. Okay, so we would have that. Now, the last case, so case number 4, is the same thing, except now you've repeated the S's, right? Okay, and now you pick, okay, the same, so the same letters. Instead of the S, there's an O, but this is the same exact thing. So 15, 4 factorial over 2 factorial to get that out. And now you have all the different cases, because there's no other cases. The only other case that is remaining, okay, is, when nothing is repeating, but we just did that as case number 1. So now you have to add this plus when they both repeat, when only one repeats, the O repeats, and when only the S repeats. And when you add them all up, you get your answer. All right, I'll leave that for you because I think the idea was, what was the intuition behind trying to break this problem down? So this is a great problem of finding, and you do have to break down the cases, unfortunately. Okay, thanks for watching this one. So another example done.